Well, hello everyone. Thank you for joining us for today's webinar entitled Three Deployment Patterns from Experience. I have with me Alex and Chips who are joining us, who are going to co-host today's webinar. Just to let you all know, you are in the right place. This is one of many webinars that we'll be hosting throughout the month of April. So this is today's webinar here, Top 3 Deployment Patterns from Experience. Coming up next week, we will have a very popular webinar entitled Introducing the Octopus Kubernetes Agent. This will feature a new agent that we have available for Kubernetes. There's a lot of popularity around that, so don't miss out on the chance of learning about that. And then further on this month, we'll have our monthly 101 series featuring myself. And then wrapping things up, we'll have our Leader's Guide to Kubernetes CD at Scale. This is the webinar edition of a white paper that we recently published. So you can go ahead and check that out there. So once again, thank you for your time and attention joining us here today. We really appreciate it. I'll let Alex and Chips introduce themselves, but for that, I will turn it over to them. So welcome, Alex and Chips, over to you.
Awesome. Hi, John. For those of you who know me, and including John, I'm such a big fan of deployment patterns.
Oh, really? Chips, if you're such a big fan of deployment patterns, name me the top 3.
And that's exactly what we're going to do today, Alex.
Awesome. So, hello from the Kiwis. I'm Alex Klingenberg. I'm a lead engineer here at Octopus Deploy. Chips?
And I'm Chips. I am a principal PM here at Octopus. And so today, as you would have guessed, we're going to talk through our top 3 deployment patterns that work and are based on real-life customers. Working at Octopus has given us the privilege to learn from more than 3,000 customers. We've built a deep understanding of their scenarios, what works, what doesn't work. And so today we're here to share some of that knowledge with you. Now, hold on. So that's us. And so you may be wondering, why does this even matter? Well, when things go wrong, they go seriously wrong. Think about failed upgrades, service outage incidents, half-done database migrations, that dreaded Sunday 1 a.m. call. So, getting your deployment pattern wrong can lead to many fires. And so having a good deployment pattern is a key ingredient to a peaceful life as a software engineer. So we have a lot to get through today, but if you take away nothing else, just remember these 3 things are the things that I really want you to remember. First, your deployment strategy is deeply contextual to your business's goals, constraints, and risk tolerance. This means that your strategy must cater to meet the needs of your company and your organization. Second, your deployment strategy should solve the problems you have in your context today. There's no point really solving for a problem that you may have in the future. And that'll become more obvious as we walk through this. Third, your deployment strategy needs to be, am I on the right slide? Yeah, okay. Sorry. Third, your deployment strategy needs to be repeatable, reliable, and maintainable to iterate on the process. As you continue to iterate on your strategy and run through it more often, you'll uncover more and more problems to solve. It's like the river's water level will go down, and then you'll start to uncover the next layer of rocks or big problems to solve, which is why there's no point predicting the future. All right, now that I've given the full secret recipe away, let's get into it. Let me start by setting a bit of context. A deployment pattern is a repeatable process that is wrong thing. A deployment strategy pushes changes, is all about pushing changes out to your customers. Sorry, excuse me. A deployment strategy is all about pushing changes out to your customers while minimizing risks and meeting goals. Now let's just break that down. First, in a technology system, we know that you need a deployment strategy because something has changed. You've changed something in your software that you need to get out into the hands of your customers. If your system never changed, you wouldn't really need to deploy anything at all. Second, pushing that change carries certain kinds of risks, like breaking stuff, right? What we spoke about earlier. And every business has a different tolerance for this sort of a risk based on the environment that they're operating in and their constraints. So, for example, healthcare is super risk averse, whereas gaming may not be. And lastly, the deployment strategy needs to work within those constraints that are imposed from outside and internally for a company. These constraints can differ basically based on the company's goals, the type of industry that they're working in, and the type of service or product that the company actually sells. For example, your company's goal may be to enforce zero downtime, or your industry has a lot of regulations requiring immutable and traceable audit logging. Or your product needs to scale 10 times to account for peak time usage and then scale down. In other words, you need a strategy to help you deploy your changes while meeting your company's goals and being in line with the company's risk tolerance. Right. So now that we've established what a deployment strategy is, let's talk a bit about deployment patterns. For me, a deployment pattern is a repeatable process that's a combination of steps and decisions that enables your deployment strategy. It enables you to push those changes out to customers and get that value out. And so going forward, I will probably likely use the word pattern and strategy interchangeably, as to me, pattern is simply the implementation of the strategy. Now, I know when we talk about deployment patterns, lots of people think about blue, green, canary, rolling, and so on, right? But for the purposes of this talk, we will class those as rollout patterns, which is the final step of deploying your changes. All right, so everyone with me so far? Yeah, cool. Um, Now, let's start us off with those top three patterns. We're going to actually talk about them from the lens of industries. And the three industries we're going to tackle today are consumer SaaS, retail, and finance. And as I mentioned, although they're presented as generic examples, they're actually fully based on what we've seen at Octopus with our customers. And so for each of those industry examples, we will also walk through their deployment patterns, which will include why, so the why behind their business goals, their constraints, and what matters to them the most in the context of their software systems. The what, how they might actually structure and implement their CI/CD pipelines. And lastly, the rollout pattern or steps they use to actually ship the changes out to customers. So let's jump into our first example.
All right,
Over
I'm
to
going
you,
to tell you all. Oh, thanks, Jeff. I'm going to tell you all about a consumer SaaS example. So this might look a little bit familiar to hopefully some of you in the audience. So, pop quiz. What was the number one thing Ship said in our takeaways? The answer is that your strategy is really deeply contextual to your business. And so we're going to start by setting some context around what a typical B2C SaaS application is going to look like. So for this example, and hopefully relevant to a few of you, we've chosen microservices. And you can see I've got like a lovely little microservices diagram here with typical scalable microservices, probably containerized, with a discrete data store attached to each service. We've kind of hand waved away anything in between the microservices and the actual front ends. And we've, had a nod to inter-service communication. Maybe you use an event bus or some sort of Kafka-esque thing that your cloud provider offers. What's really important on top of these microservices is two things. One to note is that we've got a domain-driven design approach here. So each of these microservices is innately tied to a part of your business's domain. It models that domain, right? And the example that we're going to use, taking it through our whole diagram, is going to be the identity service, which is shared by nearly every system that I've ever built in my life. So The example that we've chosen here is going to be like a language learning app. You all might be familiar with some big examples of these, maybe ones with an absolutely unhinged owl mascot. So if you were building something like this, you're probably going to have people interacting with it in a few different ways. Your customers are likely going to be focused on a mobile application, and they probably also have a web page available to them as well. So browser, web page, browser, mobile app, both of these very nice, shiny, customer facing. Everywhere I've ever worked, we also have an admin portal, and you're going to need your internal team to be able to manage kind of the content of your language learning app, you know, the modules, the learning, all that sort of stuff. I've usually seen them as like absolutely ancient server-side rendered like forms-based apps. Maybe you're doing better, but regardless, that's another sort of slice of the things that we're going to need to deploy. All of these things that talk in different ways to our lovely collection of microservices. So let's also talk briefly what's important in SaaS as well, generally speaking. You've got to move fast. Moving fast is key in a SaaS business, especially in the B2C world. You're going to have a competitor, maybe they're better funded, and you need to be able to innovate, you need to be able to deliver features, you just need to constantly keep that wheel turning. The other thing is scale. So microservices are generally known to be relatively scalable. You can have elastic capacity to meet demand during peak times. It's also a very good way to scale up your developers, right? To get them more parallelized, all contributing at the same time to multiple different services. And finally, availability. You've got to be highly available. I can guarantee you your competitor will tell everyone that they have no downtime. So with these three things in mind, let's talk a little bit more about the next slice of business context. Thank you, Ships. We're going to talk about our CI/CD pipeline here. And we're going to come back to this part later, but please note that we have a pipeline per service, right? And parts of it are probably going to be reused across all of these services. We're going to want to be able to deploy to multiple different environments, perhaps in quite different ways, depending on what the service is. Places that I have worked that are really cloud native, as far as I know, local development for cloud native applications is not a solved problem. Often I've seen people sort of connecting up to ephemeral cloud resources, so the developers can actually connect their machine up into an ephemeral or entirely emulated environment. Often there are also these ephemeral environments to bring up. Perhaps you've got a set of changes that you want to test out, show someone else. So that's often still part of the development process, but we do need developers to be able to push up their code and actually bring up an environment that tests out that code. Finally, general QA kind of environments, and then we move on to our production or production-like environments, like staging, prod, stuff like that. So our deployment is going to need to suit all of these different things, meet all of these purposes. Microservice life, it's probably going to be kicked off by a push from GitHub. I'm not going to get into monorepo or any of those discussions. You do you. Regardless, the important part is that your service is a discrete, independently deployable unit. That's what's really important here. Right, let's finally dig into that CD box. We're going to talk about everyone's favorite rollout strategies. Moving up the ships. Thank you. Cool. So we're going to turn this back to this business context that we talked about at the beginning in a moment. You'll see down here, I have given some examples of common rollout patterns that people use to achieve these kind of aims. Generally speaking, what we're looking for in a SaaS application is zero downtime deploys. That's such a buzzword. I'm personally not convinced that it's actually like a fully achievable thing, but we can get our deployment windows so small that it doesn't matter, that it is not going to affect your customers, right? So the constraints that we're going to look at here are pretty harsh, and these are actually going to end up applying to your developers. Because what happens with these type of rollout strategies that I've talked about, that I've mentioned down here, like blue-green deployments, rolling deployments, the kicker is that you're going to have two versions of your service in production at the same time. And the way you do that is pretty strict developer hygiene. So It's going to look at things like incremental database migration, because to really get the benefit of something like a blue-green rollout, you need to be able to, 1, get an early signal when things are going wrong, 2, roll back, 3, not have your service absolutely explode because the database is in a different state than your service currently expects it. So there are all sorts of patterns you can apply to database migrations here. Yes, it is patterns all the way down, but this is something that just developers need to be aware of, right? And as I said, you have to have versions of the same service running in parallel. Again, there are ways to do this. One popular thing I've seen is feature flags, where you preserve multiple code paths in your code, and then you have something independent of your deployment process that allows you to control switching between these things. And finally, inter-service communication has got to be carefully versioned. So, I spoke about event bus or other, intermediate sort of communication or data store things. Versioning is important there, but it's also really important if you have service-to-service communication, just HTTP or RPC calls, whatever you want to do. We have API versioning. It's a well understood problem somewhere. But these are tough constraints on your developers. So let's talk about why you do it. The benefits here are, right, we're going to get pretty close to zero downtime. Because you're running these versions in parallel, you can sort of allow one version of the service to drain away naturally as you move traffic to the new one, if you're doing something like a rolling deployment, or you have a nice sort of switchover point when you're doing blue-green. So this constraint actually gets you that really lovely customer experience that you're going to need. Rollback quickly based on early signal. Blue-green is pretty good for this. Again, so is rolling deployments. This means that your availability is going to be impacted as long as you can detect these issues early, right? So you start seeing a small error rate, automatically you go, okay, never mind, we're going back, never mind. And you can come back and fix it without impacting your customers. And finally, it just gives you that speed of innovation. Because your services are decoupled, they can be updated independently. So you're not sort of doing big batch changes, which, as we know, is risky. You don't want to do that. We can do lots of small increments as frequently as we want. And if we stick to these principles, we're going to be pretty safe in how we, in the impact of the changes. All right. So they hurt, but so the constraints hurt, but it's going to be good for you. Whew, okay, we're running fast. We're going to continue running fast. So we've got a lot to pack in. We're going to move on to our retail example now. I hope you guys like diagrams. We spent a lot of time on them, and I think they're pretty awesome. All right. I'm going to talk you through a retail example now. Here in New Zealand, we absolutely love DIY. There are a few very famous brands, so we're going to sort of imagine that we're in one of those. Again, hopefully some of you are working in retail that does still have physical stores. So, looking at the business context of retail, we have a lot of different systems, most of which are fairly shared. So, for example, you might have your global and local inventory management system. Probably going to have a bunch of stuff in the cloud coordinating all of that complexity. You're probably going to have, a retail front end, online retail. That's probably going to look very similar to the SaaS app. So we're just going to, set that one aside for now. We're going to focus in on deploying to fixed or mobile hardware in the store. Things like point of sale systems, whether that's by the checkout operator or self-service, payment machines, and often people have like a handheld little tablet thing that they do stock take on, or help customers find stuff, right? So I've got this range of devices that all are going to be talking to these shared services. And again, what's important for retail here in particular, the software is not the star of the show. Your job here is to not disrupt the business. No surprises. Don't interrupt the seller, right? So we're going to talk about the ways that we're going to achieve that. And we're going to start talking here about really large scale. Because scale in cloud, we handled that with the microservices. We can't do the same when our scale is hundreds of thousands of physical devices. All right, let's take a look at one of the ways that we model this. So, likely going to have a lot of physical stores. You know, I'm from New Zealand, but here over in Australia, over in Australia, you have like 5 states. Over in the States, you have like 50. You can get pretty giant, even just within one country, you can get like a pretty giant volume of stores. So what we're probably going to do is look at those stores typically in a tenancy kind of model. In some cases, we'll be modeling it perhaps on the region, you know, if that's a state maybe. And so then even within the stores within that state, we also have lots of devices, and we need to update all of those. A super fun thing as well is if you've got so many stores, you're going to be hitting some really varied network quality. Some of them might be a bit rural, some of them might just have poor network. It is not the same problem as deploying to our pristine cloud environment where we have SLAs and SLOs and all this wonderful stuff that gives us a lot of confidence that the cloud is going to be there when we deploy to it. So what we're going to do is, for each of those device types in this example, we need to deploy to each of those when we make a change. And so I want you to remember, we're going to have multiple applications as part of a single deployment. All right, Chips, move me over. Awesome. CI/CD pipeline. So previously we talked about a pipeline per service. Here we're talking about a pipeline per product. And that product is probably going to require, so you've got like some fancy new rewards program that you need that you need a bunch of your devices to understand. We're going to want to deploy to all of those things in a single go. And so that's why we have multiple deployment targets, probably with multiple applications that are deployed as part of a single pipeline, because it's important to batch those changes together so that all of the systems understand what you're talking about with this fancy new thing. So environment lifecycle is probably, with physical hardware, going to be a little bit different from a cloud thing, but we're going to have a roughly similar view of development environments, quality testing, you know, environments, and finally prod or prod-like environments. And again, our deployment pipelines need to be able to deploy to all of these. So we need that to be automated and we need it to be really repeatable. Remember how I mentioned the network quality? Network quality and the things that are important for the business, no surprises, do not mess with silent things. We've seen a common amount of time for a deployment to take in this sort of style is approximately 10 minutes, right? And that doesn't sound like much, but if that's one set of devices or that's one store, we're going to have a look at how that scales. All right, Chips, move me over. I feel like someone from like Star Trek, yeah, like, beam me up, Scotty. It's been going through my head the whole time. All right, so when we come to rolling it out, we're not actually looking at things like blue-green deployments because the things that we're bringing up and down aren't ephemeral microservices, they're actual physical devices that we need to go to. And so what we do here is we tend to have a scheduled downtime point, which means that we need to be able to schedule our deployments to match when the stores are closed. And when you're globally distributed, that's going to be all hours of the day, right? If you're unlucky, you're never closed. That's a tough problem. Let's talk about that one later. Not in the store, but generally, interesting problem. Scheduled downtime, we're going to match the store closing hours, and we're going to need to be able to batch up the things that we're going to do, and we want it to make sense. So a batch is going to target multiple stores, right? Chips has done some great maths here. So let's say we've got a deployment window, which is 4 hours, maybe per time zone. We've got 10 minutes per store, and our deployments are fairly sequential. That's giving us something like 24 stores inside that window and 4 time zones. So roughly rolling up to 100 stores a day, rolling up to 700 stores per week. In the best case with these constraints, this is where kind of batching up your changes and being really clear about what's in that change set is important. Because remember, we're not the star of the show here. We need to not interrupt the people who are selling stuff to our customers. And so, yeah, don't worry too much about things like blue-green deployments. Worry about enabling them and how unobtrusive and predictable the deployments can be in a scenario like this. All right, that's all from me on this one. Ships is going to talk you through the most complex example now, so I'll hand back over to you.
All right, thanks, Alex. Okay, our last example for today is going to be from finance. And for finance, we've chosen banking. So imagine a friendly local bank that you go to. Maybe it has a yellow logo locally. It's spread across many states and regions, and that's where you keep all your money, you spend your money, all of that kind of stuff. So the reason banking is so complex, and is probably the most complex of all these examples today, is because, firstly, they're highly regulated, right? They're regulated by the government and also international bodies. And so money is very serious business. So yeah, just a lot of rules and compliance in their space. They also serve many customers. So as you can see here in this business context, they're serving us, the consumers, right? We interact with them through online banking. Maybe we do some share trading. Maybe we get money off our ATMs, right? They also have their internal staff who uses a lot of software to make their lives easy. So whether it's at the teller in your branch, or whether it's home loan calculators or doing AML checks, there's a bunch of stuff they'll use. And then there'll be a bunch of backend systems that are either shared or actually link up to other third-party systems, like the government's, say, open banking standards, or third-party solutions around fraud detection, compliance center. But yeah, to highlight that, the core of banking essentially is transaction processing. And so that's pretty much the topmost thing that we expect a bank to do, is to move money from A to B. So remember, that's the core. But yeah, there's just so many other systems too. A lot of these systems are homegrown applications. Maybe they have a long history. Maybe they've gone through a cloud native transformation, right? Some of them are contracted out through other software vendors, and some of them may be acquired, possibly even, right? So in a bank, because of such a mix of systems, it's really no point of mapping an architecture, because they all will have their own architecture, and you'll end up with this Frankenstein monster diagram which no one can make sense of. Essentially, it's just too hard, right? So in a banks, you always look at the different lenses of the architecture and map out things that only concern the changes you're trying to make. Other constraints that we need to keep in mind with a bank is, because, again, all of these various systems have various availability needs, and that's based on the customers that they're serving. So again, for the core system where transactions matter, high availability is key, right? Downtime literally costs money. And it's been estimated that in the US, especially, an hour of downtime can cost an average of $9.3 million in a bank, right? It's a lot of money. And so having that 5.9 availability for the core is key. But then for some of the other stuff, like home loan calculators and things, right, you don't need that high availability. Right. Other constraints to remember, again, there's a high volume of money being moving through banks, so large transaction volumes, and they need to be processed with very high accuracy. Even just like a 0.001% kind of error can cause bank to lose hundreds of thousands of dollars, right? So accuracy and at a high volume is key. And lastly, as I've kind of alluded to a few times now, they're regulated, so security and compliance is crucial, and maintaining a tight audit log that's shareable, visible, and cannot be it cannot be meddled with is key. So now that we've kind of summarized the constraints in the context of a bank, let's see how their deployment strategies look like. So we've been talking about pipeline per something, right? We talked about pipeline per service, per product. And in a bank, we can think about it as their deployment pipeline is per component. Again, as I mentioned, their systems are made of a mix of legacy, old, new kind of third-party systems. So many architectures means they'll have many different types of pipelines, and no single pipeline will satisfy their needs. Here are just a couple of examples of how changes might move through for some of their components. So say, for example, it's a cloud native component, it'll move through your traditional dev test QA. And in banks, I've noticed mostly they actually deploy to multiple clouds. So they use multiple cloud providers with a mix of private and public. So, that adds a little bit of a complication there. But yeah, that's an example. Another example is for some of their legacy components, they may not have an automated pipeline at all. The progression through all of these sort of environments that they've set up may be very manual and may involve just hand testing and hand rolling to their air-gapped hardware eventually. What's common though? All of the deployment processes will need approvals in most environments. So it's a gated progression always through all the stages past your dev kind of testing stage. All right. And so how does a bank manage to roll out all of this? Well, because of the complications and constraints that we've spoken about so far, their rollout strategies or patterns are very, very manual and controlled. There's a specialized operations team that's whose job is to solely manage deployments, right? They've got a schedule, they figure out which systems or which parts of the bank can deploy at what time, and they specialize in moving changes to production. And so they're manually orchestrating all of these deployments, right? And part of it may be automated, part of it may not be, but it's still a lot of organization. They've, as I mentioned, it's sort of scheduled. Different parts of the system might have different downtime requirements. For example, when a branch closes, systems in there are good to be upgraded. So, different downtime requirements, and therefore it's all scheduled in. The other thing is also, as I mentioned earlier, the core of banking is maintaining that integrity of transferring money and transacting. So maintaining the atomicity of those transactions is crucial, right? And so before any big changes happen into the, that touches that core part of the bank, draining of transactions is the first step that happens. And as we know, things can go wrong. We need a controlled way to roll back as well if things do go wrong, right? And so the bank uses this concept of managing change sets across multiple systems. So every part of the architecture or system will have a change request, and there'll be a list of change requests that's compiled together in a change set, which then represents the current state of the full system, right? And so that's the current one, and they'll have a new change set where all of the new changes that the development teams push through will be represented. And that kind of gives them that, that box that can be rolled back from A to B or B to A, right? And it also gives them high level of auditability because you know exactly what changes are being done from A to B. And the last step is manual acceptance testing. So again, as I mentioned, everything's controlled. So at the end, there's someone sitting there, sort of a team, maybe many teams, verifying that the new change set is good to go, and then informing a go, no-go decision or whether to roll back. And so all of this allows, meeting of those original business constraints we spoke about, which is managing different availability needs, managing different downtime and rollout schedule, rollout needs, managing auditability, traceability, security. So that's how we look at a bank. And to wrap this up, I'll hand over to Alex.
Thank you, Ships. All right, there's a lot of info to take in a fairly short time. So I'm going to take you back to our key takeaways, which is essentially, number one, I hope that what you've seen on the slides is actually not too far away from your business, right? A lot of what we're talking about is so contextual and fairly specific. Your business may have a mix of these needs. But the reason that we are focusing on your business, right, and not just what your software is or what your current deployment pipeline looks like, is that the deployment needs are actually so deeply contextual across your entire organization. And so for a lot of these things, to achieve these deployment ends, the changes that you need to make throughout will be across your entire organization. And it's a lot easier to get people aligned on those things if the outcomes are demonstrably aligned with the business's goals. So I can tell you that that sort of fully automated CI/CD pipeline that some places have, it's not the reality for a lot of organizations. And honestly, for a fairly good reason in a lot of cases. So thinking about your business context gives you a really good target for you to know what's important for your deployment processes and the things that you want to change. So you want to keep moving towards that goal, right? Automate away a piece at a time. Because as you solve the problems of today, you're going to see tomorrow's problems. So keep focused on what's there now, because it might not be the problem that you expect it to be. And so this is why it's really important that your deployment pipeline is clean, so it's understandable by humans, right? Has all these amazing, great pipeline features like good hygiene between steps, repeatable, all these things. And so you want it to be automated, and if not automated, at least well documented, so that it can be repeatable and reliable. Because what this gives you is the ability to iterate quickly and effectively, which gets you back to those shiny OKRs that we spoke about in the business context, the things that we're aiming at. And then we're going to rinse and repeat and do it all over again. Awesome. So that is it from us. Thank you so much for listening. We hope that you've picked up something to take away. If you have any questions, I'm sure John can direct you to the right spot. All right. Thank you all.
Absolutely. That was great. Thank you very much, Alex. Thank you, Ships, for that great presentation. Just to remind folks, if you're all curious, you can find out more information up on our webinars page, which is at octopus.com/webinars. We talked about this at the beginning of the presentation. And if you want to see this event in person, if you're attending Open Source Summit in Seattle or CDCon in Seattle later this month, you'll be able to see Ships and Alex in person deliver this session at this event. Don't miss out on this. It will be a great event. And so we're really looking forward to seeing what they have to say about this event. Anyways, thank you everyone for joining us on today's webinar. Ships, Alex, thank you very much. We'll see you all in Seattle. And until next time, happy deployments, everyone. Take care.